If you're building anything with open-weight AI models, then you absolutely have to know about a critical piece of the puzzle, the Harmony response format. Today, we're going to break down exactly what it is, how you use it, and why it is so essential if you're working with OpenAI's GPT-OSS models. All right, let's get right into it. We're going to cover what Harmony actually is, and then we'll break down its core ideas, which are roles and channels. From there, we'll pop the hood and look at the raw prompt format itself, and then the easy way, how the official library makes it all a breeze. We'll see it in action with a full tool calling example, and then wrap up with why this whole thing is such a big deal.
So first things first, what is Harmony? Well, this isn't just a friendly suggestion or a best practice. It is the mandatory, structured chat template that OpenAI's GPT-OSS models were trained on. If you don't use it, they just won't work the way they're supposed to. To put it simply, if you are running these models yourself, not going through a service like Hugging Face or Llama that handles this for you, you have to use this format. It's the language the model understands for everything, from a simple chat to complex function calls, and even its own internal reasoning.
Okay, so how does this whole thing work? To really get Harmony, you just need to understand its two fundamental building blocks. Roles, which define who is talking, and channels, which define the purpose of what the model is saying.
Now, what's really important here is the hierarchy. Every message gets a role. You've got system for the high-level metadata, developer for your main instructions, user for their input, assistant for the model's reply, and tool for the output of a function. And here's the key. There's a pecking order. System instructions will always override developer instructions, and developer instructions override the users.
Then you've got channels. This is how the model keeps its thoughts organized. Think of the analysis channel as the model's inner monologue, its chain of thought, which you'd never show to a user. Commentary is for all the back-end chatter, like making tool calls, and final is the polished answer that you actually present to the user.
So what does this actually look like in code? Let's peel back the layers and take a look at the raw prompt format. It's all built using special tokens that act like the grammar of the conversation. Every single message, doesn't matter what the role is, gets wrapped in these start and end tokens. Inside, you've got a header for all the metadata, like the role and the channel, and that's separated from the actual content of the message by that message token. You always start with a system message. This is like setting the ground rules for the entire conversation. It tells the model critical stuff like its knowledge cutoff date, how much effort to put into reasoning, and what channels it's even allowed to use.
Right after that, you add the developer message. Now, this is where you put what you probably think of as the system prompt. It's where you write your instructions for the model and define any of the function tools that you want it to have access to.
And finally, you add the user's message. To cap it all off, you signal that it's the model's turn to speak by adding that simple Start Assistant token. This entire block of text, with all these pieces together, is the raw Harmony prompt you feed to the model. As you can probably guess, trying to build that whole raw format by hand is, well, it's a pain. It's tedious and it's super easy to make a mistake. Thankfully, OpenAI gives us an official library that handles all of that messy formatting for us.
And this right here is why you want to use it. Just look at the difference. On the left is that complex, kind of clunky syntax for defining a tool by hand, and on the right, clean, simple, easy-to-read Python code using the Harmony library. It's just a massive improvement for developers. And getting started is as easy as it gets, just a pip install. What's really cool is that the library itself is built in Rust, so it's super fast, but it has first-class Python support. You really get the best of both worlds, performance and convenience.
All right, let's put all these pieces together. We're going to walk through a complete tool calling example from the very beginning to the very end. This is where you can really see the power of using roles and channels correctly.
So here's the flow. The user asks a question that needs outside info. The model first thinks about how to answer it. Then it calls the tool it needs. Your application gets that call, runs the tool, and hands the result back. Then the model uses that new information to put together the final answer for the user. Okay, so step one happens in the analysis channel. This is the model's private thought bubble. It's looking at the user's question and thinking, Okay, they want the weather in SF. I have a getWeather function. I should use that. Again, the user never sees this part.
Next, it switches to the commentary channel to actually make the tool call. Look how it specifies the recipient, functions.getWeather, and it passes the arguments as clean JSON. That call token at the end is critical. It's a stop token. It basically tells your program, okay, I'm done for now. It's your turn to execute this function. So, your application goes and runs that get_weather function. It gets the result, and then it injects it back into the conversation. It does this with a tool message, where the role is the name of the function itself, and it's addressed right back to assistant.
And here it is, the final step. Now that the model has the weather data from the tool, it composes a helpful, natural-sounding response in the final channel. This is the only part of this whole back and forth that the end user ever actually sees.
So you might be thinking, wow, that seems like a lot of steps. Why go through all this trouble? Why is harmony so important for the future of open-weight models? It really comes down to two things: standardization and, more importantly, reliability.
It's because all this structure leads to reliability. When you enforce a format like Harmony, the model just gets it. The data shows that about 85% of models can use these special tokens effectively. That means the model has a much better sense of context, and it can separate its internal thinking from the final answer it needs to give. And that improved understanding leads directly to a 90% success rate in actually following the message structure. For a developer, that's huge. It means more consistent, predictable behavior from the model, which is the absolute bedrock you need to build a reliable, production-ready application.
So this leaves us with a final thought. Harmony isn't just some weird, quirky format. It's a framework for making open models dependable. It helps reduce the chaos of everyone just making up their own prompt formats. And it could be the standard that finally lets us plug these powerful open models into the really complex, tool-heavy applications of the future.